Hey, hello everybody. I can see a lot of names in there. So hi Dolly, let's see. OX 420 Academy, Alexis, Alien Conglomeration, Alien Gathering, Anna Banana Casino, Commander, Farming Girl, Lizzie Magenta, Roboganko, Rogue, Roxy, Sophia, and Violet. So I don't know how many of you are left from the last stream or are here anew, but welcome. It's glad to see uh, some people out there. So, all right, and there's someone I can't see in that list, but happy Monday to you as well, Ed. Um, and Dawkins, hello. D. Hawkins, although Dawkins is what I saw. Okay, D. Hawkins. Anyway, welcome everybody. We had a good week in our class. So everybody who was enrolled did most of the stuff. I think only a couple people didn't get in on the discussion, but um, and only a couple of people didn't get in on the lab, but for the most part, everybody at least got in there and got something accomplished. So it's a good start, and hopefully we'll all get our legs under us and um, get the routine of the class, and then just find that getting all the work done is not too burdensome. We don't have exams in here. We don't have any kind of homework questions, so it's just and maybe not just is underselling it, but some coding work every week. Um, this week is when I think we should start thinking about the first project as well. And then also the discussion, which is not meant to be burdensome, is just meant to, hey, we're all here, we're all working together kind of stuff. Okay. So I just was finishing posting grades from all the labs. So I do, when it's appropriate or when I have a thought, I do put comments with your lab scores. Hopefully you see those and you go look at them. So hopefully if you put a an Easter egg in your code somewhere for me to find, I did manage to find it. I mean, obviously I saw several of them. So that was cool. Nice touch. Um, but if I did, then hopefully I said something about it in the comments, unless I had something more interesting to say. Um, okay, so we are in week 2, and if I refresh this page that says I need to grade that assignment, watch what happens. Aha, they're all done. So your discussion scores are all up, your lab scores are all up. I still have to find my workflow because I have 6 different sections, which is an unusually large amount. But I'll do my best always to get scores out to you early in the week. The projects might take me deeper into the week when that happens, but your labs, I try to turn those around fairly quickly so that um, you have a chance to kind of look at what you did last week and my comments and your score about it before you proceed to the following week. This is herbal tea with honey, so I'm trying that approach. Okay, so we're just kind of we're boot camping C++. So I know a lot of you, if you're Butte College students, then you probably took Go for your first semester. So we're taking a few weeks to give all of you the confidence to know that your Go skills and knowledge perfectly apply to C++. You will find that the same will be true for your classmates who even may have some C++ background, that we dig in deeper to the C++ syntax than most people will have done in their first semester programming class. So we're all good in terms of being on the same playing field, at least in my opinion. So we're either warming up on or getting quickly up to speed on working in C++. It looks to me like no one had any big problems with last week's lab, so that's encouraging. I will sort of as just my comments about most people did this just fine, but the kinds of things I look for in terms of your coding style are that it is consistent throughout. Pardon me. It just happy Monday, Magenta. So you should endeavor to be consistent in your coding style, just because it's off-putting, and you'll have this experience too. You're reading someone's code and then it looks different from, like, suddenly it's being done different from the way they were doing it above. In industry, that's not the kind of thing that people do. Most programming teams or shops have a style that they're all expected to follow, so everybody's code looks the same. And the reason why they do that is because it's difficult to read and understand and maintain and add to code that is being written in a style that's not your own, or that's not one that's agreed upon by everybody who's working on it. So I try to be adaptable in the sense that if you have a style, I let you use it. The thing I ask is that you be consistent with it. Be consistent about the way you use spaces, blank lines, spacing between operators. Generally speaking, you should also be going for making your code readable, because I have to read it and you will have to read it sometimes when you go back and work with it. So think about the fact that you can socially engineer your teacher by making your code a pleasure to read as opposed to an inconsistent, nasty mess. So there weren't any inconsistent, nasty messes in your code, but there were a few inconsistencies here and there. So let's get that cleaned up and make you look like the skilled programmers that you are becoming. Output style. I'm taking this from the agenda. The same thing on your output statements, the stuff that prints to the screen. It should be consistent, but you also need to think about the information you're presenting to the person running your program, which is often myself, and whether or not they can easily read and sort of check the correctness of your code. If you're making that job hard, you're making it more likely that things will be missed. If you make it easy and make it a pleasure to look at your code, like, hey, look at this person, took the extra time to do that little extra thing, took them 10 seconds at most out of their life to make my life easier. That's a big deal. That's a big deal when you work on projects with teams of other people, which you will do someday. It's a big deal when you are showing your work to potential employers or teammates, that you take the time to do that kind of thing. No one wants to work with a programmer who's a slob. So that kind of thing, I just try to get you in good habits as best I can, because I want you to come out of my class the kind of person who's got the skills and the style that other people want to work with you. The last thing from week one. So many of you, not many of you, some of you managed to get it in there that modulo is for integer division. And it's really only meaningful for integer division, even in a language like Go that allows you to get away with it, in my opinion. But in C++, the modulo operator is for integer division. It is not for dividing numbers. That is a term that less precise people than programmers would use. Modulo is for getting the remainder of an integer division. So if you were specific about that, I praised you in my comments on your lab. And if you weren't specific about that, then I didn't say anything. But just make note, like, we're also going for some precision in our terminology. All right, so those aren't really complaints or criticisms. Those are just things that we want to have it be our habit. Consistent styling in our source code and our outputs, and precision in our use of terminology. We can get down into the weeds of things as programmers with complex algorithms and lots of data. And the more precise we are in our communications, the better life is for everybody. Then we can actually solve problems and not solve the problem of talking to each other or communicating with each other. Okay. So this week we're going to be doing some more warm-up in C++. We'll look at sort of broadly the data types and initializing or declaring and initializing variables, getting just comfortable with performing inputs and outputs on the screen, on the console, branching statements, that would be if else, if, and switches in C++. And then finally, looping constructs, which in C++ there are several of them. And then finally, we have a lab this week, which is a rock, paper, scissor game. Rock, scissor, paper? Rock, paper, scissor? I forget. Rochambeau, if you like that term. Which I'll make note of again later, but And that's what the random numbers is about. How do we get the computer to kind of make their play randomly? But one thing to note about yourselves in terms of your skill level is that I am giving you this rock, paper, scissors game as a lab to complete in a short amount of time in 1 week of the semester. And that is something to take pride in, because if you go back to the beginning of your first semester and I had given you that program, it would have been much bigger and more complex than a new programmer would have been able to do in a week. So that's something to be proud of, that I can give you a problem like that and know that, and I know and you know that you have the skills to knock something like that out without being overwhelmed by it. In fact, it's a small amount of work for someone with your skill level. So that's a very cool thing, in my opinion. The reason why we do a rock, paper, scissors game is because we can use it. It will force you to use at least one loop and to use one or more decision-making constructs, branching constructs. So that's why I like it for an exercise. Is the problem is easy to understand, and it kind of compels you to complete it, to use and practice some of these fundamental constructs of programming, which is branches and loops and variables. And then knowing how to handle random numbers can be useful sometimes. Okay, so there we go. That's the whole kind of setup. So I'm going to walk through the module first, and then I'm going to switch over to my Replit. I'm going to create one, and then we'll explore some of these ideas. And then I'll add in a little bit of detail as I go about, for example, that namespace stuff. Come over here. Okay, so just a reminder, you can get to, at least I think you can, get to everything important about the class from the course homepage. Am I on the right place? I am. So where I am and how to contact me, and then all of the content. And then the highlighted rows are important due dates, which are the projects in this class. So we are on week 2, the week of August 29th. So I'm going to go there. I'm going to step through the parts of the module, and then I'm going to go play around in code and Replit. Okay, so we're going to create a Replit project for Lab 2. This is a random kind of response, but I can tell, like, ask yourself, if you submitted a lab during week 1 where you didn't name the lab 1, you should think about what that tells me about your level of effort in the class, because I spent time during the live stream talking about how the REPLs are named randomly and how you change the name in 2 different ways, why I'm using the naming that I use. And there were, I remember one project that was submitted. No surprise, they hadn't done anything but put their name in it. And why you would put your name in poo is a mystery to me, but they put their name in it and they left the name of the REPL random and didn't do anything else. And I thought, well, what am I supposed to think? What is this person telling me about themselves? Just a thought. Okay, so we're going to create a REPL and I'm going to name it properly. We're going to declare variables. I'll talk a little bit more about data types and initializing variables. We'll do some I/O. We'll use flow of control, and then I will also talk quickly about how to get some random numbers going. So these readings are here. Some of you might want the readings as refresher. I noticed the buttons aren't coming up. So the readings are there for you to consume as you want. These are the readings from my main sources that associate themselves with the work we're doing this week. You do them or you don't do them. That's up to how much you think you... there they come. I was waiting for the buttons. How much you can or can't make use of that information. Um, yeah, that's all I can say about the readings, since I don't quiz you on the readings or have exams on the readings. Those are just there as support or supplemental material for your use. Then we have the lab. So um, I'm going to read it and then just kind of have it stick in my head. If you don't know rock, paper, scissors, I do have a link to a write-up about what the game is, but I think most people do. There's no shame in not knowing what the game is, but you can go watch YouTube videos about it, or you can read about what the game is. Most people are familiar with some variation, at least, of rock, paper, scissors. All right, so the instructions: go on a REPL, create a REPL, name it Lab 2. Don't name it whatever, because I'm too lazy to put a name on it, or at least I want people to think I'm too lazy to do that. Experiment with the settings again if you want to sort of get comfortable in REPL it. Implement a game, which seems to be missing all the bits and pieces. But that's okay, because it's rock, paper, scissors game. So I'll sort of give you a starter, especially for the random numbers part, and they'll let you go from there. Documentation is points. Formatting the source code and the output neatly and really consistently is points. Use at least one loop in there somewhere so that the player can play multiple rounds of the game. Use counters to keep track of the number of wins the player has, losses, and draws when playing against the computer. And then finally, a fully functional rock, paper, scissors game where the human plays against the computer that's making random selections. I'm going to make one edit because I see a colon in here that I don't want. Okay, so that's the lab. Following the lab is your class didn't have. I think your class was the only class of mine, maybe the assembly classes. You guys did. Thank you for reading the instructions and finding the filters and attaching your contributions to the class discussion. Not all of my classes were consistently good about that. So every week's going to be this same routine. This week you'll find the week 2 filter, the link. You'll find a discussion for this week, and then I will ask you to contribute to a discussion. In this case, you may or may not be aware, but C++, I mean, it's kind of the old player, and it's got a huge amount of fans, but there's also some newcomers that are gaining a lot of traction, and some not so newcomers. So JavaScript still super popular. Java pretty popular for some kinds of applications. Python very popular, especially among like AI people and mathematicians. The Go language is slowly moving its way up popularity because they're backed by Google, and people tend to trust their technologies. The Rust language, which is backed by Mozilla, and that one is growing in popularity, I think. So the question to discuss is, what is it about C++ that's valuable for a computer science student? I'll give you one, but you can still discuss it, which is memory management, or, and these are just hints, the absence of garbage collection. Those are things that make computer science teachers like C++ to teach with. All right, anyway, that's the discussion. And then the last thing is the reminders. And now we have calling your attention to the fact that the first project's out there. So my plan for today is to go through coding examples, work ourselves toward a basic setup for the rock, paper, scissors game. And then after that, we'll look at the first project and start to think about what we're going to need to complete it. This doesn't work for everybody, but you shouldn't wait until the Sunday night that the first project's due. You should look at it soon. I would hope that you would even start it soon. kind of working out how you're going to solve the problem, and you can identify things that you need to know to solve the first project, and then look to find that information or look for it to be delivered to you during the live stream. Okay, so that's where we're at. So I'm going to go to Replit. Make sure that you can see okay. I'm going to create a REPL. So remember, there's 3 buttons to do it on the Replit screen. So there's the create button at the top left, there's just the plus button on the top right, and there's the create button kind of in the middle. Use whichever one, they're the same. So I am using C++ in this class. I am not going to take somber prudent generics. I know I already said this, but then I saw it in a student submission and I thought, really? So for me, I'm trying to keep my REPL project separate between programming algorithms 1 and 2, which is why I'm putting the tag on it. So I'll know this is lab 2 for this class and not lab 2 for the Go class. So this kind of thing, though, the way you name things, that people assume that says something about you, or at least it says something about what you want people to think about you. When we've interviewed people to work at our college, as an example, and people are asked to send a series of documents, some people take the time to name their documents with nice looking, consistent names on the files themselves. And some people look like they just couldn't care less. And then they send different document types. And so I won't tell you what I think, although you probably know, but you should ask yourself, what would you think if you saw a submission from one person who took the time and was obviously organized enough to use the same file types and use a consistent file naming, versus someone who it appears said, who cares anyway? Okay, so I don't think there's any starter code. Is there a starter code this week? If there is, no, there's not. Okay, so I meant for us to work from a blank screen. So I'm going to go over this little bit of S standard : C out. I hesitate to do this a little bit because I don't want to confuse people. Yeah, let's put off. No, let's not put stuff off, or should we? I was mulling this over before. Yeah, let me go ahead and just try a little example so you can see what this is about. So in C++, there's multiple layers of organization. Sort of the highest level of organization is just by using files and separating out things into different files in our code. So this IO stream, that's referencing a specific file with a set of definitions in it. The definitions include some functions, and they also include some things that are more or less variables or objects, if you know what that means. So we start with sort of the one level of organization is simply put like things in a file all together in one place, which is what this include is doing. Is I want to access all of the stuff in that one file. But there's a next layer down, which is called namespacing. And namespacing allows you inside of a file and even across files to sort of create a category of items under this, what's the word I would use for that? Reserved word of namespace. So you can create namespaces for yourself, and then within those namespaces, you can create things like class thing. I can create just a function. So, and then you can put these in separate files. Now, I don't want to get too far into this, but I just want you to have a sense of what this std::: is about. I hate it that people don't know. I think you should know fairly early on what it means. So I'm actually going to create a new file. I'm going to call it boy.h. I'm going to put my namespace in there. I have my class thing and my function f. I can have variables if I want to. All kinds of stuff. So if I wanted to use anything in this file, I would include it. Now, because it's a file in the same folder, I would include it as boy.h. And then I could say, I could use the class thing from within the namespace Boyd and call it T. So what I'm showing you here is that the thing in front of the : is actually pulling a specific namespace out. Now, in this file, I could have other stuff. I could even have other namespaces if I wanted. But it's just a way of organizing material. That's all it is. We use files to organize material, coding material. We use namespaces to organize coding material. But then when we want to use those items, we have to get at them through these various layers. So you need access to the file that defines all that stuff. And then if we have things inside of namespaces, we have to go through the namespace to get through the thing that's defined in the namespace. I also had a function in there. So I hope that makes a little bit of sense of what this : stuff is about. You don't have to get hung up on it a whole lot. But I'm about to tell you what your options are in terms of how you use these namespace layers of organization in your code. So I'm going to get rid of this boy.h because it's just garbage. Get rid of the references to it. So I just wanted you to see that we're just talking about ways that things are organized. So it's not always clear. As an example, how do I know that the namespace std is in IOStream? Well, other than the fact that I remember it, I could go look at c++.com and I could find that this item cout can be found within the namespace std, and then that stuff, those two layers would actually be found in the file iostream.h somewhere. All right, so that's some craziness. But there are options for dealing with namespaces. So some people, another teacher at our school, Luke, this is his style. Some people think that that's a good idea just for not losing track of where things came from. So cout came from the standard namespace. When I'm teaching, I find that cluttery, so I tend to eliminate it in one of two ways. One thing you can do is you can say, using that entire namespace, so I want everything that's in that namespace, and then when C++ sees something like cout, it knows that this is one of the places it can go look for that. And if it finds it there, then C++ is happy. If it doesn't find it there, C++ will not be happy. I changed it to xout, and xout is a non-existent thing. So some people would argue that this cout just sitting in your code like that, it's not clear where that came from exactly. But I like the clutter freeness of it. And then there is one other way that you can do this, which is actually my preferred way when I'm actually working in C++, to be honest. You can say that I want, from the standard namespace, this thing specifically. And now it's a little bit easier for a human reading this file to see from the top, oh, the couts in here are all coming from this namespace. what some people don't like about this style is that it requires you to do this for all of the bits and pieces that you might use like that. So some people think that the top of the file starts to get a little bit cluttered. But this is my preferred style, although often when I'm teaching, I go with the most simple way of doing it. I hope that's tracking for everybody who's watching. So I will go back through the three options that you have. One is you include the file that has what you want in it, and then if there are namespaces in there, then you resolve the items from their namespace. Or you can kind of put that work all on the C++ compiler. So you can just tell the C++ compiler, whenever you find something that doesn't appear to come from anywhere, look here, which is the least cluttered way to do it. Or the problem with the least cluttered way to do it is that other programmers, other humans reading your code may not be able to make the connection as easily. Oh, that's a good question, Magenta. So the question is, does using a namespace limit your access to other libraries? It does not. So it's a very good question. And actually, using namespaces is a way to keep names from colliding with each other. And I'll put my Boyd back just to show you that. No, I won't. I'll just tell you. So if I had a cout defined inside of my Boyd namespace, then if I told C++ that it's the Boyd : cout and not the std : cout, then the compiler can keep those two things separate from each other and not confuse them and assume that there's a duplicate definition and emit an error. So namespaces is actually a way to reduce the number of errors while allowing programmers to possibly reuse the names of variables, classes, structs, and functions. Hopefully that makes some kind of sense. So it actually gives us more freedom when we are creating our own code to not accidentally overlap someone else's code, which means that it's easier for us to use more libraries, in fact. That's a good question, though. Okay, so this is the least cluttered. And it's nice when you're teaching because you don't have as many lines of code that aren't very interesting. But it also means that a human programmer kind of has to make the mental leap for themselves. So I prefer sort of the middle ground, which is I have a listing of the specific items I'm using so that a human programmer can see, okay, wherever I see cout down there, that's the standard namespace is cout. So that's kind of a balance so that when you get down into the meat of the code, at least, all of the extra clutter is way at the top of the file and we don't have to worry about it anymore. So this is my style. Use whatever style you prefer. We're not going to get into anything. Yeah, we're not going to have enough layers of libraries anywhere that it's probably ever going to matter. But you are going to see me use this style because it's the style that I personally prefer. Because I think it's a good way of, it's a way of using code to document what's going on in it, which I like. Okay, so there's that. So we need to do branching, and we need to do looping, and we need to do some random number stuff. So I'll just quickly review the sort of branching setups and the looping setups, and then we'll go from there. And then I'll also kind of talk about my preferred style. You can use whatever style you want, but be consistent in your own code with your style. And I have one thing I have a lot of experience at is reading different people's code with varying degrees of skill and experience. So that's something that I've developed, I think, is an eye for kind of noting what your style is and noting when you should stray from your own style. If in doubt, you're very invited to use my same style. Um, and you may find as you go on that you'll work with people who have a different style that they want everybody to use, but mine is a fairly common style. Okay, so let's do some decisions. I'm just going to give myself an integer, start it at 0. So I prefer, as an example, this style of initializing variables because I just think it looks pretty. You can use the initializer style. This would be called the constructor style of initialization. And one of the reasons I like it is because you can end up doing something like this. So now we're going to talk briefly just about initializing variables. So maybe someone in chat can. I'll see if we have some brave souls in chat. Are both of these variables initialized? Maybe we're shy in chat. I'll give it a nice one. So this nom points out correctly y is initialized, x is not. And that's an easy thing to miss if you're using the initializer, the assignment style. And the same would be true if I said x equals 0, y. Only one of them is initialized, which is the x in this case. So yeah, great job, Isna, Magenta, D. Hawkins, and Ed. That first example, only y was initialized. So in C++, you need to be in the habit of initializing your variables. In my opinion, you don't want to introduce garbage data into a program by accident. If you are coming from Go will initialize variables for you, and that's expected and that's good. C++ will not. So when you're working in a language like C++ or any language, you need to know whether or not it will initialize variables for you. And if it does not, like C++ does not, then you need to initialize your variables. Or you may introduce garbage data into your program, which means that you may introduce bugs or outright errors into your program. Okay, so in this case, now I've moved the equals 0. So to do the sort of using the assignment operator style, you'd have to do x equals 0, y equals 0. You can, of course, put them on separate lines, and that's just fine. My personal style is to use this sort of constructor approach. And I just find that it's easier. I find that I am less likely to forget to initialize a variable because for some reason I can see that quicker than I do the other thing with the equal sign, with the assignment operator. So anyway, that's my style for initializing variables. And you should do it for all variables. You should do it for bools. And again, that's my style. You should do it for chars. It could be anything, but you can do it for floats. Technically, you can put just 0 to initialize a float. I put the .0 just because it's an extra piece of information on the screen that reminds me that that's a floating point variable. Okay, so good question, Magenta. So if a variable is not initialized, in C++, it's actually defined, but it's going to pick up data from the underlying memory location, whatever that data is at the time your program starts to run. So it's not undefined, it's actually just garbage. But I'll print an uninitialized variable out and see what we get here in just a moment. That's an excellent question, though, Magenta. So no, uninitialized means garbage, not undefined, but garbage, which means that you can't test for it being undefined. You can't test for it being a particular value representing its uninitialized state. It just is garbage, and um, so it's you want this habit. Same for doubles. So you can use the assignment style, B equals false, C equals Z, F equals 0, and so on. But I like this style with the parentheses. I just think it looks pretty. That's why I like it. So let's print them out real quick just to see. Sometimes it's going to look like not garbage. It'll be 0, and other times it'll look like garbage. So I'll say X equals. So notice, by the way, I'm putting kind of the spacing around here so that it's easy to read on the screen. And that's quite on purpose. Oops. So there's the downside to my style of these using directives, is that I need to remember to get them in there. So let's see. I'll put a note next to X that it is intended to be uninitialized, whereas Y space is initialized. That way our output, we should have a return 0 down here. That way our output reminds us what we're looking at. So notice I took the extra time just to put the little piece of information in there, which could be helpful down the road, and it didn't take any time at all. So there's X, it's 32. Why? Just because it's the garbage that was sitting there where X is in memory when I ran the program. And in theory, that can change. It's still 32 now, but that kind of thing can change over time too. So, well, not once the program's running, but anyway, there's an example. So X is 32. That's completely unpredictable. And we don't want unpredictable. So make sure that you initialize variables. And I'll call you out on it when I see it. And usually take a point or two away, if not more, because I want to hammer home the idea that you need to be in this habit in C++. You don't want to be the person who crashed a spaceship on Mars because you didn't initialize a variable. The satellite that crashed on Mars, by the way, the problem was that they were doing conversions in the English system and the metric system and had not coordinated themselves. So the calculation was correct in the wrong system, and the thing was smashed into the face of Mars. I can't remember when that was. But the same kind of thing could happen if you don't initialize a variable and you're writing in C++. Which I think one of you mentioned SpaceX, so that's a place where you would. Write in C++ probably, and you don't want to be that person. Okay. There is one more data type I'm going to hit while we're on data types, which is the string. So to use strings, you need to include strings, and then it turns out that the string header file also adds things to the standard namespace. One of them is the string type. It's actually a class. So the trick about strings is that they aren't primitive data types. It is a class, which means that it self-initializes. That just takes getting used to, but strings self-initialize. What they initialize to is nothing, so I'm going to put some quotes around it in the output so we can see it. So S is this, a length of so bools are primitive. They need to be initialized. All the integer types, we're going to use ints mostly, but there are other integer types. They're all primitive that they need to be initialized. All the floating point types, which is floats and doubles for us, need to be initialized. Chars are primitive. They need to be initialized. Strings, as it turns out, are not primitive. They are a class, and that means that they self-initialize, and we will right now look and see what they self-initialize to. So they self-initialize to empty string with a length of 0, no characters. So strings don't need to be initialized, but they can be initialized if you want. You can initialize them manually to be empty string, or you can initialize them to some random string if you want to. So strings will self-initialize because they are not a primitive data type. They are a class, and classes in C++ self-initialize. So now S is Taco Cat with a length of 7. So strings are a little bit different. And they are a common type that we use. Okay, I'm getting rid of that so that we don't get too distracted. All right, so there is roughly 15 minutes on some style issues, some precision issues, precision in terminology issues, this namespace mess. Like it or hate it, it is a fact of life in C++. There is a reason for it, and I'm glad Magenta asked that question because we got to talk about why would they do such a thing. And they're not the only language that does namespacing type things. In the Go language, they call them packages, and they're roughly similar, even though packages often live in a file. Okay, so now we need to do what I started back on, which is let's look at the decision-making constructs quickly, just to remind you of the setup. So we will start with, I'll just make an integer and I'll make it be 10, and then I will write an if statement. If x is greater than 10, greater than 0, just to remind you of the different sort of setups and show you my style as we go. So you can use ifs like this, right? Which would trigger a piece of code or nothing if they're triggered. This one should trigger, of course. So x is a positive integer because I initialized it to be greater than 0. So you can use sort of standalone ifs this way, because sometimes you have code that you only want to execute in a particular situation, but there's not sort of an else part. There's not the other thing I would do. Sometimes it's I'm going to do this one thing or I'm not going to do anything. The other thing you'll notice about style here, I do I forget what this is probably the KR style. But in terms of the curly braces, I like the curly braces at the end of the opening line and then kind of lined up with the thing that it opened when it closes. So that's the curly brace style that I use. The other thing about curly braces is that I use them on all of my constructs, even when I don't have to. So in C++, if you've only got one statement, it's okay to not use the curly braces. But I think that's not a good idea because you can end up with a situation like this. You might accidentally kind of just come back to the code later and write code that looks like this, which is not what you intended, of course. Because the tab tells me that I probably wanted that to be connected to whether or not x is greater than 0. But it's not. Right? Oh, I showed it to you. Why? Because without curly braces, the if will only attach to the one statement. So I believe that you can eliminate a whole set of errors just by always using curly braces, mistakes in your code. So now if I were to come in here and write this, if I were to tab it over, I would think, well, that can't be right. Something's weird here just by the way things are lined up. Or if I put it here and I see it come out and I think, oh, crud, I meant for that to be part of this grouping, then the grouping's kind of already there waiting for the fix to come in, right? So if I run it now, nothing happens, of course. And if I change it to be something greater than 0, so that's a long way of saying I always use the curly braces, even if I don't have to. I always use them because I think code is easier to read. It's easier to maintain. It's less likely to introduce some dumb mistake that I didn't intend because I thought I was being slick with using less curly braces. It doesn't add enough to the weight of the code on the screen, in my opinion, to try to avoid them. So there you go. That's how I would do that. So there's an if statement. We can also attach an else to it. This is one that kind of dogs new programmers. And what I mean by that is that new programmers don't like this sort of the else that seems to not be connected with any piece of logic. But it is connected to a piece of logic. It's connected to this piece of logic. So will someone in chat, since you guys are a good active group, what is the logic? What's the condition that would get me to the else part? I haven't put the statement yet, but in sort of plain language, there is a condition in the logic that gets me into my else part. That's true. That the if part is false. And another way to say it, I like the way Ed Cass said it as well. Almost. We're getting there. Ed and Isnam are close. The else part tells me that the if part was false. That's true. But the else part tells me something about X as well. And those answers are correct, but they're not all of the answer. Does anyone see the missing piece of logic on the else part? So we would get in the else part if it's not true that X is great. Could be 0. Good, Magenta. So the else part tells me that X is less than or equal to 0. And I don't need any logic. I could certainly write it. But no programmer is going to do that because it's just introducing more complications into the screen. It's making the code harder to read, not easier to read, because we would recognize that an else part would be conditioned upon the if part. So if is X is greater than 0, then else must be X is less than or equal to 0. I will make it be that. And I will make it way be that. Okay, so there's an else part. Now let's go to the third layer, which is sometimes we have 3 or more conditions we're interested in. So else if X equals 0, else. So this is how people would write it. And at a point, maybe you start to lose track of the logic. But it's still the way people would do this, right? So if X is greater than 0, we do one thing. If X is exactly 0, we do something else. And then finally, what's left is X must be negative. Then we do the last kind of option. Did I leave it as negative? I did. Okay. So We don't have to have the else part. We can just have we are only interested in numbers that are exactly 0 or positive. And we could ignore the negative numbers. Depends on the situation, right? So the else part is not required. And so on. We could also have I'm not going to fill in the gaps anymore. Hopefully I'm not going too fast that people, well, you can see it on the video and pause on that if you want to. So I'm not going to get a good code sample until we get to the rock, paper, scissors game, which I'm starting to pay attention to the time. Okay, so we could end up with something like this. And notice how I'm stacking the else ifs following the closing brace of the section above. That's my style. If you use a different style, just please be consistent about it. So we can have as many branches as we want. So maybe we want to know if X is 1 or 2 or 3, and that's all we care about. Or anything else that's not 1, 2, or 3 precisely, we could handle that differently. You'll notice, by the way, if you may or may not have used an editor like this, the arrows on the side. So they don't do anything. They are just a way to manage your screen real estate. It's called folding. So Replit will fold matching sets of curly braces. So I can fold the if section. And it's not doing a very good job of this, but all it does is kind of let you compress the screen. So there I can fold up all of main. We might use this occasionally when we get some nasty functions going. Okay, so there's the if else, if else, if else, if else. Decision constructs. If you're coming from the Go language, you'll need to get used to the extra parentheses and the extra semicolons and stuff. It's no big deal. Your fingers will develop muscle memory for it, and it won't be a problem. But the editor will show you typically if you're making a mistake somewhere. Something will start to look funny if you do it wrong. So those parentheses are required in C++. So I didn't do any of the other kind of decision-making stuff, or x equals -1. The logic building in C++ is exactly the same as it is in Go and most other C-like languages. So you have the logical OR, you have the logical AND, which is double ampersands, which, by the way, this is impossible. X can't be both 1 and -1. You have all of the comparisons: less than, greater than, less than or equal to, greater than or equal to or equivalent, which is 2 equal signs, not equal to, which is exclamation point equals. Those are all the same from most of the languages that you guys would have come from. Those are all the same. If you're coming from Python, they like to use words for some of this stuff. So you'll get used to the symbols in C++. And that's all in the readings if you need to review the operators for doing these decisions. Okay, let's do then the switch style. So in C++, this is different from Go. Go can switch on most kinds of things. C++ will only let you do switches on integers and character types. I'm not a big user of switch. There's certain situations where I think, oh, that makes my life easier. But I tend to be heavy on my use of if-else for my decision making for whatever reason. But anyway, just note that in C++, you are limited to writing switches for int and char types. So I can certainly switch on the value of x here because x is an integer. And then just like in Go, we have case statements. So we can say in the case that it's 1, do stuff. And then we need to be careful that we put a break. So this is different from Go. in Go, you don't have to put the break statements. Go just assumes that when the next case starts, the last case ends. But let me just show you the problem here. And again, this is all reviewed in the reading, so I'm just kind of talking through the things that I know might catch people out. So this is a switch like we might write it in the Go language. I'm going to make X B1. And then I'm going to fire this off, and we'll see the problem in C++ that we need to get used to with switches. The first problem is that you can only do them on integers and characters. The second problem is they flow into each other unless you stop that. So notice here X was 1, but it actually triggered both the case 1 and the case 2. That would not work that way in Go. Go would just stop at case 1 and then that'd be the end of it. But in C++, the cases flow into each other. So what we need to do at the end of a case is put a break statement which marks the end of that section. And we should do it for every section, even if it's the last one. Just like using curly braces always, I recommend that you always close every case section with a break so that if you come and add some later, you don't accidentally make a mistake. All right, so now we fixed that behavior. Okay. So why would they flow into each other? Well, let me just show you one example of how we can take advantage of the flow between cases if we want to. So we can do something like this. I'm going to switch this to be chars, and I'm just going to make it BZ, little z. So I can do this now. I can switch on C, and I'm going to say case little z, and then I can use the flow to stack the cases. So that I can get the output on the little z or the big Z, because the little z will simply flow right through to the big Z. So that more or less I'm using a switch to get a case-sensitive comparison. And I could do that for all the letters if I wanted to, or whatever letters I'm interested in. I can stack the cases. So that's the only thing I ever really use this for, is to get sort of a case-insensitive comparison this way. So if C is Z, if the character is a little z or a big Z, they both flow to the same result before breaking out. So there's switch. Those can be folded as well. Okay, that switches. My goodness, how am I going to have time? I'm going to have to really speed up here. But there are readings to back it up. So let me give myself the X back. Just make it 0. So I'm just going to quickly show you the setups for the different loop types. I don't know that I'm going to have time to do a for each loop. I might have to carry that over to the next one. All right, so the loop types in C++. We have the while loop. And the thing to note about the while loop is that the while loop can execute 0 times. It can be the case that the while loop fails to meet its condition and never executes at all. That's useful to know, that a while loops execute 0 times or possibly more. This while loop will not execute because X starts not greater than 0. So the loop can't even execute. Now, there's a difference between that and a do-while loop, which is a funky-looking loop. And again, these are reinforced by the readings, I think. So if you need to kind of review the setup, a do-while loop, for Go, you're used to kind of using one kind of loop for everything. C++ has multiple kinds of loops. A do-while loop is guaranteed to execute one time because it does not check its condition until after the fact. That can be useful sometimes. I'll show you an example actually in setting up for the rock, paper, scissors game. So the do-while loop is guaranteed to execute one time and possibly more. A while loop may execute no times by its design. So we will see the do-while loop fire and not the while loop. It's going to fail after one attempt because x is not greater than 0, but it does the one attempt because it's guaranteed to, because it's in a do-while loop. Okay, then we have the for loop, which is more what you're used to from the Go language, although it's not nearly as flexible. Pardon me. So the for loop has all of the controlling variable activity in the loop itself, typically. So we have the controlling variable I being declared. It's only declared the first time and not redeclared as the loop repeats itself. We have the condition that is checked always at the beginning of the loop, including the first time through. So a for loop can execute 0 times also. And then we have the controlling variable adjustment that happens at the end of the loop body. So the first section before the loop ever executes, the second section at the beginning of each attempt to make it through the loop, the third section at the end of each time we go through the loop. So this one will start at 0, and then when it equals 5, it will bounce out before executing. So it'll go 0, 1, 2, 3, 4, and then bounce out. You can also, if I were to initialize the controlling variable to 5, that's going to fail before it ever executes even once, because this is always checked. So the for loop never executed because it failed to meet its condition even the first time through, and that can happen with for loops. Did I write? I think I did. I did. So I'm going to show you because I think I have time to do it anyway. Those are the critical ones for us right now. I'm going to show you the one other that you're going to see us use a lot in coming weeks. And also, I just think it's really cool. There is another kind of loop that you will see a lot in this class. These are the ones that you're going to want for a lot of your logic. I'm going to use a do-while loop for my starter for the rock, paper, scissors program. I lost my place. Here we go. So let me give you one other kind of loop. This is on the video, so sorry about that. Hopefully that's big enough that when you see it on the video later, you can pause on it and grab that stuff if you need it. But of course, I'm not doing anything interesting, just showing you what the loops look like. I'm also showing you that I always use the curly braces everywhere on these kinds of things, even when I know I don't have to. While loops and for loops, you don't have to, but I recommend that you do. That way, you just never mess up because of that. All right, one more. I'm going to add an include here for this. I tend to alphabetize my includes, but I group my usings, if that makes any kind of sense. So So I'm going to bring stuff in from the array file, which also pushes stuff into the standard namespace. So I'm going to use the standard library array because I want to do an example here for you. So I'm going to make an array of, I think I may have to fix this, of 5 integers. I will call it numbers. Can I initialize it? Maybe. Let's see. Let's see if that builds before I try to go anywhere else with it. Yeah, okay, it's not going to let me do that style. I should have figured as much. But let me show you 2 forms of a loop. You will have seen something like this, by the way, in the Go language, if that's where you come from. So I have an array of 5 integers called numbers. This is weird looking. You're going to get a bunch of this kind of thing in the coming weeks. In fact, you're going to create code that allows you to do this kind of thing. But this is the standard array. I named my array numbers. It's going to have 5 integers in it. I'm going to use 2 for loops. One to populate it, so for. So this is the for each loop. What do I want I to be? I don't know. I'll say 1. I'll make all of them. No, that's going to yeah, let's do it this way. I want you to see this. Pardon me. You're not going to need this anytime soon, but while we're on loops, we'll come back to this. This is a for each type of loop. You've seen this in Go if you took the Go language for PNA1 or have exposure to Go. So what I'm going to do is I'm going to loop through the numbers array, and I'm going to pull out each integer. This ampersand means by reference, but what that really means is I am going to access the integers in the array for the purposes of overwriting their values. So this ampersand lets me overwrite their values so that every integer in the array is now 1. Or I'll make it 10 or whatever. That's the reference to the for each loop, and I just want you to have seen it once while we're introducing loop constructs, because you're going to see us use these a lot in coming weeks. And then here's another for each loop. This time, I'm not going to pull out references to them, meaning I don't mean to alter their values. I just mean to read their values. So this is a read-write access, and this is a read-only access. And I need to be able to read them to print them. Hopefully this builds like I wrote it. So I made them all 10. But anyway, I wanted you to see that C++ does have sort of a fancy automatic kind of loop for things like arrays, and we will make use of them. Okay, that's pretty good. I did not give us a break today. I'm sorry about that. So I will try to do that. I ended up taking more time on those things than I thought that I would. Yeah, the timing's just bad. So if anything, we'll finish a couple minutes early as I get you sort of set up on the rock, paper, scissors. So apologies that we didn't get a break, and my voice is showing it. That we didn't. Okay, so I'm about to scrub all this out and get back to where I want to be for our rock, paper, scissors game. I don't need the array anymore. I don't need any of this junk. I do need to be able to read in integers, because I'm going to ask them, like, enter 1 for rock, 2 for scissor, 3 for paper, or 0 to quit or something like that. So I need the C in for reading, I need the C out for printing, and the N line for line breaks where that's handy to do so. Now I'm also going to need, I think I need CMath, math, and I think I need CTime. For random numbers. So those two includes at the top are to facilitate the creation of random numbers, which is the first thing I'm going to do is just sort of get this program making random numbers in my desired range. So I need both of these libraries. The process for creating random numbers in C++ is the same in Go, it just the code looks different. So the process is you seed the random number generator, which is you kind of set up the random number generator algorithm to get reasonable and different looking random numbers from one execution of your program to the next. So that's this part, seed the random number generator. I'm going to seed it to the system time. So all this is really doing, the random number generator spits out basically an infinite sequence of integers. By seeding it to the system's time, which is a moving target, I actually kind of start the random number generating process at different locations in this infinite list of integers, which means that every time I run the program, the time will change, which means that my starting place in the sequence changes, which means that the random numbers look more random than they might actually be. That's a lot just for that one line of code, but that's what's that about. You only do it once. I do it at the very top of main in a program where I'm doing random numbers. If you read the documentation, you will see that reseeding the random number generator makes it be less good. So you seed it once and only once, and you do it at the top of main and nowhere else. I'm saying this in the video because I'm going to see this done in people's code in other places, and I will know that they didn't watch the video. And then I will feel justified in saying that's wrong and don't do it anymore. Okay, so I have seeded the random number generator. Now I'm going to use it to generate a random number. So I am going to int. This random number is to represent the computer play. So I'm going to use the random number generator to get an integer. Now I've used the assignment style here, the equals symbol, because I'm about to move this around a little bit, and you'll see why I need the equals here in just a bit. So all I'm going to do, though, as an experiment is I'm going to generate the random number, and then I'm going to print it out. And then I'm going to run it and see what kind of number I get. All right, I get a very big, nasty number. And if I run it again, it should be a different number. Run it again, it should be a different number. So at least the random number generator is working. And if you want to convince yourself that seeding is necessary, take it out and run this program a few times and see what happens. If you don't seed it, you start in the same place every time. You get the same sequence of numbers every time. So seeding it guarantees that I get, it doesn't necessarily guarantee it, but there's a better assurance I'm going to get a different number. If I choose a starting place in the random number sequence that's moving with the time. Okay, so that's close except for I want just 1, 2, or 3. I don't want numbers. In fact, well, let's say 1, 2, or 3. And then we'll play around with that. So does anyone in chat know how I get it down to 1, 2, or 3? there's a trick of the math, and I asked you a question about it. That's the hint, to get you thinking about something we can use that is a sort of a math trick to get this random number to not be gigantic. That's right. So I need to get this down into a range. So the problem in C++ is there's no way to get this function to do the range for me. I have to somehow cause the range myself. So nice. So it's mod. So one of the great tricks of mod is that you can use it. So if you mod 3, the only possible remainders you can get when you divide an integer by 3 are 0, 1, or 2. Now you're down into your range. 0, 1, or 2. And then if I take that, and I'm doing the parentheses in part, just so it's clear to you what I'm doing. But also I just think the algorithm is a little bit clearer this way. So first I get my 0, 1, or 2, and then I add 1 to make it 1, 2, or 3. So this trick of using mod to take a number of unknown size and kind of constrain it is a great trick. So good job in chat. So let's run it a bunch of times. He didn't want to play 2, but now the computer's decided to play a 2 in there somewhere. So most of us programmers, by the way, in our code, we'll just kind of get rid of, we'll just kind of change our logic. That's up to you. If you think it's clearer to have the +1 in there, but a lot of programmers will just say, well, I'll just write the logic for 0, 1, or 2, because that's what naturally comes out of this math process. And then I could have put this in a loop. Just to kind of, in fact, I just will, right? Let's just do that. Let's just do it 100 times. All right, so we'll just do that 100 times, and we'll scan it just to make sure that we're only getting 0s, 1s, and 2s out of it. Yeah, looks good. So if you want to add 1 because it kind of reads better on the screen, there's nothing wrong with that. I'm just sort of saving the add 1 and doing it this way. Also, just to give you the idea that you can do that. All right, so there's my little, just did it 100 times just to feel confident. All right, so there's the computer play. So I initialize the computer play with the random number, and the player, since I'm going to have to ask them to type it in, I'm going to initialize that to 0 before I ask them. So the requirements don't have you fix it for the user if they put in a wrong number. So that's something to consider, though. They could type in a 4 here and get away with it. So that would be a challenge you could take on for yourself to prevent the user from being a dummy. Okay, oops, I should have put a new line there. All right, so there is that part, the computer getting a random number, the player choosing something. I mean, it would be nice right here, wouldn't it, to say, if computer play equals 0, then the computer plays rock. So that 0 is rock. I hope everyone gets that. That 0 is rock is because I just made it be rock. That's why. Because I'm the programmer and I just said it's rock. This is going to have an else if. And it's going to have an else. If you know how to use functions, of course, you're always welcome to do that. If you don't, then you'll be happy when we get functions in the mix. So same for the player. So if the number's not matching, kind of messes with your sense of order or the way you're going to do the logic. Just pay attention for that. But notice that I'm converting the numbers that I need for my logic into words that look pretty on the screen because it doesn't take that long to do it and it looks so much better. Oh yeah, but I didn't finish it, so I get compiler errors. I forgot. Okay. And then we're going to have way down here, so we have the random number generator. Then we have computer plays a random selection. Player plays. And then what is the result? What is the result? Which is going to be a big long if, else if, else if, else if, else if kind of thing. There's lots of combinations and oh, did the video go blurry for some people? Sorry about that. It could be your end or my end. But I'm going to post this sample, so don't worry about this. I'm going to post this part as the as sample code, so that'll be okay. All right, so hopefully everyone kind of followed the setup. So the computer plays something, the player plays something. We have a big old long if, else if, else if, else if, else if, else if, with all the different combinations of what the player played and the computer played. Then we are going to need, I wish I could fold it, but I can't. We want all of this stuff. The computer playing, the player playing, and the result to be looped. I believe that a do-while loop is a good way to do this because if they started the, oops, I don't want that. What key is that? F12? No. Hold on, I don't want that. F7? No. What's the key? 9? I don't know. I don't want this. How do I get this off? I don't know how to get it off full screen. And I can't see you guys anymore, so I don't know. Ah, here it is. Oh, thank goodness. Okay, so we want to loop all of this stuff. So I'm going to wrap the whole game sequence, tab over, into a do-while loop. So the computer plays is inside the do-while loop. The player plays is inside the do-while loop. Figuring out the result is in the do-while loop, which you need to give them some way of getting out, right? Like maybe here at the bottom you can say, that kind of thing. Okay, so all that's in a loop. So the last thing I'll leave you as a hint, and I will post this. So you're also required to keep count of the number of times the wins, losses, and draws. So the counters need to be created before the loop starts because you don't want the loop overwriting the counters every time. You want those to change over time. So the counters need to go above the loop. And they need to be initialized to 0 because it wouldn't make sense for there to be any other value for them to start. So wins, losses, and draws. That needs to be initialized before the loop starts because the loop, when you figure out the result, is going to be adjusting those counts. And then at the end, after they have this while loop goes back one, at the end, then you can report the values of the counts and say goodbye. So there's my whole kind of getting you set up. It's 11:31. So thanks for being patient. I need to get in the habit of getting us a break somewhere in there. But I felt a little frantic because I found myself spending so much time on some things. So I'm going to post the code at the bottom of the lecture page. There will be code samples, and I will post this code as a starter for you. There are readings to supplement what we talked about today. So if you need things about how do I increment a counter, how do I write out an if else and compare values, that's all covered in there. Good question. So this will be, I'll answer this and then we can close. So in terms of commenting your code, I'm a minimalist when it comes to commenting code. So the comments that I have put here are about as much as I would typically comment. So I've sort of made a comment for the major sections of code. Seeding is kind of its own section. You could say counters, but that's pretty obvious. The computer playing section, the player playing section, the results section is about as much as I would comment the code. So generally I comment less because I don't want to spend a whole lot of time looking at comments, just enough to give me a handle on what the section looks like. So I'm sorry, that's kind of vague, but not too much. And a comment like this, get input and get out of loop, is wanted. Once that code is written, I would delete that comment because the code should be obvious to anyone who's a programmer what it is that it's doing. So for me, the comments are really just there so that if someone's quickly scanning the screen and looking for a particular section of the code, it helps them find the section. But once they're in the section, then the code should speak for itself. Okay, so that's it. I think we're all graded up. If you have questions about your scores or something specific that you want to contact me about, Canvas inbox. If it's a question that we can share out with the rest of the class, that's always my preference because I've found that often your classmates are quicker at getting the answer to you than I am. But also I like the idea that you can all share in the answer to whatever the question is. So questions about this, try to limit the amount of actual code that you share because you don't want to give people the solutions. You just want to help them get over their rough spots. So that'll all just take some practice. And if someone puts more code than I'm comfortable with in Piazza, nothing bad's going to happen. I may just edit it and say I took a little bit of the extra code out because it was a little bit more than I would have in there. So use your best judgment, and then I'm always there if you have a question, or I can make a correction, and nothing bad's going to come of it, and then we'll kind of learn. We'll kind of negotiate a contract, as it were, for those kinds of things. Okay, so I'm going to stop there. I'll post the code, and the video takes a little bit longer because it's got to go out for a little bit of processing. The Twitch video is immediately available, and the YouTube video usually gets there pretty quick. The captioned one and then my updates to the course pages themselves take a little bit longer. So I will try to get that all done before the end of the day today at the latest. Otherwise, very much enjoyed having you guys here in the chat. I very much appreciated that you interacted and asked questions. So appreciate it, Edcast. I hope you have a great week as well. Everybody have a great week. I did not get to talk about the first project at all. So I would encourage you to go read the specification for it. And then hopefully I will make or leave time next week to talk about that. Anyway, take care. I'll see you next week.